Now welcome everybody to this latest video on 162 Maths, and in this video we're continuing with the series of going through some big mark questions taken from some GCSE Maths higher exam papers. Now there'll be a copy of the questions for you to have an attempt at before watching through this video as we go through the answers, which I strongly recommend you do just to see how much you know and how much you understand from the question just from reading it. And I'll also include the mark scheme, as sometimes there are more than one way to get the right answer, and you can see if it's a valid method that still gets you full marks. Now, as you can see from these big mark questions, that a lot of the questions do have a mixture of topics included in them. Now, some of them will have common links, but some of them can be extremely random. So it's just a case of recognizing the question, trying to decide what topics it relates to, because it will make it a lot easier to recall key informations that you're going to need to know and call upon your knowledge to answer the question correctly. So let's get started on question 1. Now, question 1 says that VABCD is a square-based pyramid. The horizontal base ABCD has a side length of 10 centimeters and a center of M. Angle VMA is 90 degrees and angle VAM is 68 degrees. And it's given us the volume of a pyramid, which we would expect because it's a complex 3D shape. And the question is asking us to work out the volume of the pyramid. So looking at the formula, what we can see is we need to know the area of the base, which is not a problem because that is a square, but it's the perpendicular height that is missing for us to straight away work out the volume of this pyramid. So the first thing I need to do is I need to work out what this length here is, which I'm just going to call H. Now, in order to find that, you can see that that is linked to a right angle triangle. So you might be automatically thinking of trigonometry, but the problem with that is that in order to find H, I need to know what one of the other sides are, so either A to V or A to M. Now, looking at this, what I can also spot is another right angle triangle, and that is going to be this triangle here. Now, from this, I can see that the length AC is double the size of AM. So if I can work out what AC is, I can therefore work out what AM is. Now, to do that, I'm going to need to use Pythagoras. So here I've got that AC squared is going to equal 10 squared plus 10 squared. So AC squared is going to equal 200. So AC is going to equal the square root of 200, or you can write that in third form as 10 root 2. Now, if AC is 10 root 2 or root 200, then that means that A to M is going to be half of that. So either root 200 divided by 2, or it's going to be 5 root 2. Now, for this, I'm going to kind of keep it as 5 root 2 just to make it easier, so I'm not dealing with long decimal numbers. But it's not impossible for me to actually work out what 10 root 5 root 2 actually is as a decimal, because again it's going to be a calculator question, and that gives me an answer of 7.07106, and that number continues. So you can either use any of these three particular numbers as A to M. I'm just going to label it as 5 root 2 because I want to keep a level of accuracy. Now, once I've got that, if I take the triangle of A, V and M, that this length here is 5 root 2, this angle here is 68, and H is what I'm wanting to work out. So looking at trigonometry, because I've got one side and I need to work out another side, I know the angle. So here I'm going to use tan. So I've got tan 68 equals the opposite, which in this case is H, over the adjacent, which is 5 root 2. So then H equals 5 root 2, or you could write 7.07106, is entirely up to you, multiplied by tan 68. And if I type that all into my calculator, I get a H value of 17.5015, and that continues. So there is my height value. So from this, what I can then do is now substitute all of this into this formula to work out what the volume is going to be. So that's going to be 1/3 multiplied by 100 multiplied by 17.5015. Now, if you've left that on your calculator, that's going to be absolutely fine. So here I've got 17.5015 multiplied by 1/3 multiplied by 100, and that gives me an answer of 583.4, and that's going to be in centimetre cubed to 1 decimal place. Then moving on to question 2, it says y equals p times q to the power of x minus 1, where p and q are numbers. Y equals 10 when x equals 1, and y equals 0.3125 when x equals 6. Work out the value of y when x equals 3. Now for this, it's just a case of just substituting numbers in and knowing the rules of indices. So if I substitute these numbers into this formula, then what I end up is y equals, and it's going to be p times, well actually no, y, it should be a 10, multiplied by q to the power of 1 minus 1. Now that equals 10 equals p, do I put a times there, equals p times q to the power of 0. Now anything to the power of 0 is just 1, so then p equals 10. Now from that, what I can then do is use the second bit of information to then work out what q is. So substituting these numbers into the formula, knowing that p equals 10, so I've got y equals 10 times q to the power of x minus 1. So here I've got y equals 0.3125 and x equals 6. Substituting those numbers in, I get 0.3125 equals 10 times q to the power of 6 minus 1. So that's 0.3125 equals 10 times q to the 5. I take the 10 over by dividing by 10, so it ends up with being 0.03125 equals q5. And then if I do the sort of 5 root of 0.03125, I get the value of q. Now if you're not sure about how to access that 5th root, then if you just load up your calculator, what it should have just above your X with a little bar where you can enter your universal power button. So if I press shift and then that, I can then enter the root, so it's 5, and then enter 0.03125 equals, and it comes up as q equals a half. Now that's not the final question, because the question doesn't ask me to find p and q, it asks me to find y when x equals 3. So what the formula then is y equals, and it's going to be p, no it's not going to be p, it's going to be 10 times 0.5 to the power of x minus 1. Now when x equals 3, y equals 10 times 0.5 to 3 take away 1, which is just 2, so it's y equals 10 times 0.5 squared, and again if I type that into my calculator, 0.5 squared, I get an answer of 5/2 or 2.5. Now if this was on a non-calculated paper, then what I would suggest that you do is to write your answer like this, and then from that we can write 10 times a quarter, because 1 squared is 1, 2 squared is 4, and that then becomes 10/4, which is 5/2, which is 2.5. But personally speaking, I would say it's definitely going to be a calculated paper, only because you need to work out the 5th root of 0.3125. Moving on to question 3, it says that the diagram shows a rectangle and inside a semicircle. The rectangle has dimensions of 16 centimeters and 6 centimeters, and the question is asking us to work out the shaded area. Now with any shaded area question, it's most likely going to be the big shape, or the area of the big shape. Let me just write that properly. Subtracted by the area of the small shape. Now in this case, the big shape is the arc, sorry, the semicircle rather, and the small shape is the rectangle. So I need to work out those bits of information first. Now, if I just mark the centre of the semicircle, it says that this length of the rectangle is 16 and this length here is 6. So half of that is going to be 8. So then what I can then do is use Pythagoras to work out what the radius of that semicircle is going to be. Now if I just write the area of the rectangle is going to be 16 times 6, and 16 times 6 gives me an answer of 96. So here from this we've got r squared equals 8 squared plus 6 squared, so r squared equals 64 plus 36, so r squared equals 100, so therefore r equals 10. Now you might be tempted to write plus or minus 10, which would be correct, but because r represents a length it can't be negative, so it must be positive 10. So then using this, the area of the semicircle is going to be pi r squared divided by 2. So substituting those numbers in, I get pi times 10 squared divided by 2, which is 100 pi over 2, which equals 50 pi. So then here the shaded area is going to be 50 pi minus 96. And you could factorize that, but I'm going to leave it as 50 pi minus 56, and again just a reminder, I'm leaving my answer in terms of pi, so again this most likely will appear on a non-calculator paper. Moving on to question 4, it says the Venn diagram shows information about a coin connection. The total subnet is going to be 120 coins in the collection. T represents the coins from the 20th century and B represents British coins. And the question says that a coin is chosen at random. It is British, so we know that for a fact. Work out the probability that it's also 20th century. So for this, what we need to do first is we need to find the value of x. Now to do this, what we've got to do is we're going to use this top bit of information that all the numbers in the Venn diagram have to add up to 120. So if we add up all the 4 different sections of the Venn diagram and make that equal to 120, we should therefore be able to work out what x is going to be. So here I've got this first section plus the middle section plus the other semicircle plus 32, and that should all equal 120. So neatening all it up, we get, oh, don't know why I've got a plus there, minus 15x plus x minus 2 plus 32 equals 120. And if I neaten all of that up, obviously it's starting to look like a quadratic, so if I take it all over to one side and make it equal to 0, I get an answer of x squared minus 13x, and it's going to be minus 90 equals 0. Now this does factorise, so I get x plus minus 18, x plus 5 equals 0, and so x equals 18 or minus 5. Now out of these two possible answers, and you still need to write the two answers, it can't equal minus 5 because x can't equal a negative number. So x must equal 18. So if I substitute x equals 18 into the Venn diagram, then this just t is going to be 54, because that's going to be 18 times 18 take away 15. So it's basically 18 times 3. This is going to be 18. This is going to be 16. And then we've got 32. So from this, what we can then do is look at the question. So the question saying that if it's definitely British, so we're just looking at that green circle, what's the probability that it's 20th century? And that's going to be, well, the total of it being British is going to be 18 plus 16. And that's going to be all divided from 18. So here the final answer is going to be 18 over 34, which I can simplify as being 9 over 17. So any of those two answers would be absolutely fine for the full marks of 5 marks. So now moving on to our last question, it says that the diagram shows a lawn with a fence along one edge. One can of weed killer covers 90 square metres. Each can costs £19.25. Work out the total cost of cans of weed killer needed to cover the lawn. So the first thing we need to do is we need to work out the area of this trapezium. Now in order to work out the area of a trapezium, so let me just write down the formula. So which is a formula that you do need to learn, is going to be the two parallel sides added together multiplied by the height divided by 2. Now looking at this, I know the two parallel lengths, but I don't know what the height is. That's going to be a big question mark. So that's what I need to work out first. Now if I just draw a horizontal line here, I can see that it turns into a right angle triangle, and this base of the triangle is going to be the difference between the two parallel sides. So the difference between 20 and 12 is 8. So if I then just label this as H, taking this blue triangle out, then I can use Pythagoras to work out what H is going to be. So here we're going to have H squared equals, and here we're finding one of the shorter sides, so I take away the square of the other two sides. So here I've got H squared equals, and it's going to be 225. So H equals 15. Now again, it's going to be positive 15 because you can't have negative length. So this length here is going to be 15. So I can then work out the area of the trapezium, which is 12 plus 20 multiplied by the height divided by 2. And that gives me an answer of 32 times 15 divided by 2, which is 240 meters squared. Now the next thing I then need to do is work out how many cans I'm going to need. Now I know that one can has 90, so if I do 240 divided by 90, so the number of cans needed, and I type that into my calculator. Well, actually I don't need to type into my calculator, but it becomes 8 over 3, which is 2 2/3, which equals 2.6 recurring. So I'm going to need 3 cans of weed killer. So from this, the next thing I then need to do is work out the total cost of 3 cans, which is £19.25 multiplied by 3. And again, this could easily appear on a non-calculator paper, in which you should have a final answer of £57.75.